thanks for coming. We're about to get started, so if everyone could quiet down, please. Thank you. Ian, I'm Nelson Osaki, and I'm part of the staff of Reflections Projections. Thanks for coming out here. This is Ian Chan. He's a senior software engineer at Twitter, where he has worked on web and platform team for the last 2.5 years. He graduated from the University of Toronto, studying software engineering and computer science. Prior to Twitter, he helped build user interfaces and consumer experiences for Tura, Autodesk, and IBM. And now, without further ado, here's Ian Chan.
Hey guys. So today I'm going to be talking about engineering at human scale, talking about what that really means, and kind of going into the details of some of the cool stuff that we're doing at Twitter. So I already got an introduction, but I'll go over a bit about myself. So I'm a front-end engineer at Twitter. I've been with the company for just over 2.5 years now, and I studied computer science at the University of Toronto. So I think a lot of you guys are studying that. I also did software engineering. So I'm a front-end engineer, which basically means my job is to build cool stuff that a lot of people get to use. And I kind of emphasize a lot here because when I joined Twitter, I really had the opportunity and the pleasure of deploying and building things for hundreds of millions of users. I was at a small startup beforehand. We didn't have that many users. And then when I switched to joining Twitter, it was just kind of incredible because suddenly the code that I was building and the code that I was shipping was being used by people all around the world. But in addition to my responsibilities of a front-end engineer, I'm also a software engineer, which means that it's my responsibility, it's my duty, it's my job to take like a disciplined approach to building things the right way, a robust way, cost-effective way, and scalable way. So whenever I talk about software engineering, I always talk about software craftsmanship. So this dude right here is this like 87-year-old Japanese guy in Tokyo named Jiro Ono, and he's considered to be the best sushi chef in the world. Like, of all the people in the world, all of the critics claim that this guy is the best at what he does. And he's been preparing sushi for something like the last 75 years or something like that. He basically started preparing sushi when he was like 10 years old. And that's all he's done every single day for his entire life, which is kind of crazy, right? But he has the highest rated and what's claimed to be the best sushi restaurant in the world. It's this tiny place in Tokyo that serves like 6 people or something like that. But there was recently a documentary made about him and his life, and they asked him, like, how are you so successful? Like, why is your sushi so good? Why do people pay like $400 to go eat at your restaurant? And he basically said that he chose to be a sushi chef, and when you've made the choice of what you want to do with your life, you have to dedicate your life to mastering your skill. I really suck at making sushi. I've made it once and I got food poisoning, so I'm not going to be better than Jiro. But when I graduated from college and I decided to become a software engineer, this is the choice I made. And when I joined Twitter, I'm being, my role as a software engineer, this is my skill. My skill is writing code. My skill is building products and building systems. So a little bit about engineering responsibility. It's really easy to kind of hack together code and throw stuff online and make products that kind of work or kind of break sometimes, but this isn't really software engineering. That's kind of like hacking. That's kind of like being a code cowboy. That's kind of just being a code monkey. When we talk about engineering diligence, and I use the kind of example of Jiro, like he takes his craft very seriously, I take my craft very seriously. I owe it to myself to do the best I can because I spent a lot of time in school studying. I'm getting paid to be a good engineer, so I'm not going to like write shitty code and then deploy it. I owe it to my peers because if I write crappy code, it means that like my coworkers are going to have to deal with it, or other people are going to get called at 3 in the morning because my stuff broke. So I owe it to my peers and, of course, my company. But most importantly, I owe it to my users, the users of my products, the users of the service that I'm building. Because if I build something crappy and it gets deployed and it breaks, and my users can't log into twitter.com, that's my fault, and that's my responsibility. So when we talk about engineering for human scale, we first got to start off by talking about engineering for one person. So if we're in a situation where we're building software for one person, it's a much easier problem. It's really easy to elicit feedback. It's really easy to gather requirements. If only one person's ever going to use your software, it's really easy to guess all of the good and the bad things that can happen. Because you could literally just sit with the person and say like whether it works or not. But this is like extremely rare. It's not very common that you're building software for one person. Like right now in school, you might be building code for yourself or maybe your TAs. But in production and in practice, it's really, really uncommon that you're building code for just one user. And if you're at a startup or at a company and you only have one user, there's probably like a problem and you need to like reinvestigate your business model. And in my professional career, I've only been in one situation, like ever, where I was building code for just one user. So a bit of a story. When I was at IBM, I was with a team of about 5 or 6 engineers, and I joined a project that took about 5 or 6 months, and the plan was to build a user interface for one user. So like the plan was, there's going to be one user, we're going to dedicate 5 engineers on this, which seems kind of weird, but we spent 5 months building the system. It worked, and we tested it with the user. The user liked the product, so we were basically able to perfect it. But this is really rare. So this was the user that we built the system for. This was Madhu. It was a female orangutan at the Atlanta Zoo. And I say that this isn't human scale, not because it's an orangutan, but building software for one person is not what I'm going to talk about. And this is kind of like before the iPad and the iPod, but we made this like maze game that the orangutan could solve, and when it won, it got like treats. It was like definitely one of the most interesting projects I've ever worked on. But again, it was 6 engineers building a system for one user, and we watched the orangutan use the system, and it like banged the screen and stuff. Kind of worked. We had to make really big buttons. It's kind of cool. All right, so human scale engineering is really about building stuff for end users, for a lot of users. Maybe it's 10,000 users, maybe it's 100,000 users, maybe it's 1 million users. This is a much more difficult problem because it's harder to get a grasp of what the problems we're going to encounter are going to be. It's harder to grasp what the requirements are, how people are going to use it, how it's going to scale out, how many people are going to use it. And it's a much longer feedback loop. It's kind of impossible for me to sit beside all of the millions of people using Twitter to see if it's working the way I expected. So unlike the case when I was building stuff for one user, building stuff for 100 million users is a much different story. So how does this all apply to Twitter? So about 6 years ago, before Twitter was around, there was just this sketch by Jack Dorsey about this idea he had about sharing 140 character messages with your friends and followers. So at the time, he had the idea of making this kind of cool project, and the user base was basically him and a couple other people. But since then, so 6 years later, one of the core values that we have at Twitter is we want to reach every single person in the planet. And that's like the mission that every engineer at our company has. So Jack basically always brings us up at company meetings in that he says that he wants to build a service, a communication platform, Twitter, in a way that every single person, so all 7 billion people in the world can use. And then this is what I really mean by human scale engineering. We're talking about like the human race, every single person on the planet. So what does it mean to build software where potentially every single person on the planet could use it? Whenever you talk about big scale, like high scalability and big data problems, a lot of people always focus on just the data. So big data is incredibly important. There's a lot of really interesting talks about big data. There's a lot of interesting talks on HDFS, Hadoop, all the kind of cool stuff you can do with this data. But that's not what I'm going to focus on. While the data is important, our users are much more important. No matter how complicated and sophisticated your system is, if the code isn't working, if your system isn't working, then all the big data doesn't matter, because all that matters is that you can deliver a product and get it into your user's hands. So this is a photo of Obama. He was like live tweeting during a town hall last year. And if this photo had like a fail whale in there, that would be really crappy, and that would be, really unfortunate. So we're trying to get to human scale. How have we done so far? In 6 years, we've amassed about 500 million registered accounts. We have about 140 million active users, and we're doing about 400 million tweets per day. So a bit of context here. It took Twitter about 4 years to reach our billionth tweet. This was like a huge milestone for the company. So 4 years after the service started, we had enough users that a total of 1 billion tweets were created. Now, since we're doing about 400 million tweets per day, we're doing about, 1 billion tweets every 2.5 days. So it's kind of crazy. And, a little comment, there was about 200 or 20,000 tweets while I was just reading this slide, so it's all sorts of crazy stuff going on right now. So what does this all mean for you guys? I'd like to say that this is an absolutely incredible time to be a software engineer. Like right now. Like 10, 15 years ago when I was building websites in my mom's basement, I used to have this website that had cheat codes for Sega Genesis games, and I put it on like GeoCities, and it was the coolest thing in the world. And I think after a year, I had 1,000 visitors, right? And it was like, everybody back in like the 90s had this like hit counter on the bottom of their page, and it was like the coolest thing in the world. It was like sometimes like an animated GIF with flames and like, but nobody ever had more than like 100 visits. It was kind of sad. There would be all these zeros on the front. But the first time I had 1,000 visits to my site, I thought it was like the most incredible thing, because I wrote this like, to be honest, like really shitty website using some HTML builder, and I put it online, and I had all my cheat codes. It was like all of the the fatalities from Mortal Kombat 1. And then after a year, I think this was like before Google was around, I had 1,000 hits. I have no idea how they found my site. And I thought it was really cool, because I was building stuff and 1,000 people got to use it. But we're in a time now where you're not talking about 1,000 users, you're talking about millions of users. Looking at some of the other companies in this domain, like Facebook, I think actually they just announced that they have 1 billion users, which is just absolutely incredible. Companies like Zynga have like 300 million users. And I use Instagram as an example because they went from 0 users to 80 million users in under 2 years, which is just absurd. And this means that like when you're building code, you have the opportunity of writing a simple hello world that gets deployed and used by, people all around the world. So human scale engineering is like, you're one engineer writing some code, and of course we all write code in binary, and you could be potentially shipping it to every single person on the planet. And I think that this is really cool, and this is like a really cool opportunity that all of you guys have in this room. So whether you're going to leave and start a startup, or join a big company, you have the potential of writing software that will get in the hands of millions of people around the world. So when you're shipping code for millions of people, things can go wrong. Right now at Twitter, every engineer in the company, whether you're a new grad, an intern, or you're a seasoned engineer, when you write code, you have the opportunity of deploying it. So if you join Twitter today, as an intern or as a new grad, you could write a new feature and you would deploy it. And essentially when we press that big red deploy button, the code gets deployed to all of our servers, and suddenly 200 million people are using your code. So even if it's like a one-line change, if there's an error in your code, 200 million people around the world are going to suddenly get screwed. And whenever we're planning our systems or whenever we're planning our code, and I remember doing this a lot in college, I would think about the weird corner cases that could occur, and sometimes I'd be like, all right, here's my code, it works pretty damn well, but there's like a 1 in a million chance that the user's name is like 30 characters long, or there's a 1 in a million chance that, the user uploads a humongous profile photo or something like that. But that's probably not going to happen. Or maybe there's a 1 in a million chance that the input to this function is going to be null, so I'm not going to bother checking it. Even if it's 1 in a million, we have so many users that 1 in a million corner case is probably going to happen like several times a day, if not hundreds of times a day. And if that bug causes the entire system to go down, that means our system's going to go down several times a day. So I wanted to use this time to kind of walk through and look at some of the examples of when things kind of went horribly wrong at Twitter over the last 6 years. I hope that you guys enjoy some of these examples. They're not examples of the best things that happened. They are going to be examples of some of the worst things that has happened as we've tried to reach human scale. So of course, we can't talk about scalability without talking about the fail well and failability. So let's start off with a couple examples. So when you're growing a site, and I showed you that sketch of Twitter back in like 2006, we had no idea that people were going to use it the way that they are today. We had no idea that people were going to be tweeting like all the time from all around the world. Back in 2009, in June, when Michael Jackson passed away, we reached a milestone hitting 456 tweets per second. So this was like a record of simultaneous tweets from around the world about people sharing this news, like this tragic news. And this moment for us was like a critical moment because it was, one, it was the most tweets we'd ever seen, but it also pushed our like system and our infrastructure to its limits. And after that news kind of settled down, everything went back to normal, but our system stayed online and we were okay. And we basically kept looking back at this moment as saying like, when Michael Jackson passed away, that's like when our servers almost died, and like it was kind of crazy, right? But we were okay until the Super Bowl 2010 happened. So when the Super Bowl happened, we were surprised to see sustained traffic of about 1,000 to 1,500 tweets per second from around the world, mostly in America. But people had suddenly started to really get involved and excited about Twitter. People were tweeting about the Super Bowl. People were reading tweets about the Super Bowl. And this eclipsed the record that we'd set before. Now, I mentioned when Michael Jackson passed away, our servers were basically like shaking and like we almost went down, but we didn't. When the Super Bowl happened, we were like totally screwed. So, well, the entire world was like watching the Super Bowl and trying to read tweets about the Super Bowl. This is what most people saw on Twitter, which really, really sucks. So the fail whale, I'm sure a lot of you have seen this, but hopefully you haven't seen it recently, is what we used to serve when there was like an HTTP 400 or HTTP 500 error. So basically, we served this up when the servers were timing out, when our servers were down, basically when something crazy was going on our back end. So if we look at the analysis of what happened during the Super Bowl, basically whenever anything interesting in the game happened, we would serve a fail whale because suddenly like a ton of people would be tweeting about the event. So when there was like a field goal, when there was like a halftime show or like a really funny commercial, people would tweet like crazy and then like our site would go down for like 30 seconds. And this is obviously like a really, really shitty experience. So this is back in June 2010, or February rather. This is like the first signs that we had that we were reaching human scale. Like we had no way of anticipating that people would be using the system like this. We had no way of knowing that like, 1,000 tweets per second would be coming in about people watching a football game. And we had to reflect and look at our own infrastructure. At the time, we were using a single master for all of our writes, and we were using temporal sharding for our MySQL tables, which means that basically we would split up the writes on like in segments of time. But the Super Bowl happened in a 3-hour period, so during that 3 hours, all of the writes were going to one master. We were relying way too much on memcache. All of these kind of things that got us to where we were no longer work, so we had to really rethink a lot of our infrastructure. Since then, we've rebuilt a lot of the systems. We've made this a lot more reliable, a lot more redundancy, a lot more scalable. And the most recent Super Bowl, we saw about 12,000 tweets per second, which totally eclipsed the other two, and we were fine. We were able to watch the Super Bowl instead of waking up at like 3 in the morning and like fixing things. So the lesson learned here is that you can never really expect or anticipate when you're going to have this explosive growth. It seems like 2 years ago it wasn't really that long ago, and it wasn't, but we've had kind of exponential growth for the last 3 or 4 years. And the thing about exponential growth is that every step forward it seems like you've reached a new order of magnitude of users, of tweets, or whatever, but every year or every month you go forward, it's growing like crazy. So, I mean, just looking at this, it's kind of nuts to think that we fell over just with 1,000 tweets per second. All right, the next thing I want to talk about is all of the use cases. So you build a feature, you think you know exactly how people are going to use it, but you have no idea when you give a simple feature to millions of users, what's going to happen. So let's look at a really simple feature. We have a feature called protected accounts. So this is my personal protected account that I use for testing. I look really angry there because I'm probably pissed off because something broke, but I only log into this account when something's really messed up and I have to figure out what's going on. So we created the protected account feature as a way for people who wanted to use Twitter to tweet, but you can only read their tweets if they let you. So if you guys wanted to follow what my protected account was doing, you would have to put in a follow request, and then I would have to log in and then accept it. Most people are using just regular public accounts, but there's a small fraction of the world that chose to use protected accounts, and we wanted to make sure we supported this feature. And this is kind of like a recreation of what the screen looks like. It's changed over time. But you can see a list of all the people that wanted to follow my account, and then there's a button here that says follow or accept all follow requests. So it just saves the user time from clicking down the left side and clicking accept all. So you can click one button and then you're done. So this is kind of like a little snippet of the code that we had originally used to do it. It was something like really simple in Rails where we basically just pulled in a list of all of the requests and then iterated through all of them and then accepted them all and then you're done. Like something like really easy like that, right? And this worked. This was fine. This got us to where we needed to go. That is until Lacey Duval XXX showed up. So Lacey Duval, if you're not familiar with her work, is a famous American porn star. And she decided to create a Twitter account, but she is very private with her personal life, so she did not want to make it public, which is fine. So she made a protected account, and she was tweeting with it. But people around the world who were fans of her work, I guess, they wanted to follow her on Twitter. They wanted to see what she was doing on a day-to-day basis. They wanted to see what kind of photos she was posting, I guess. And over time, she amassed over 100,000 requests. So 100,000 people around the world wanted to follow Lacey Duval XXX, this famous porn star. which is perfectly fine because you can follow your interests and you can follow whoever you want. So I don't know. I didn't follow her. I promise you. So this simple code that had gotten us so far, when we ran into Lacey Duvall, really killed us. So what happened here was, and this was when we were using, I think, Rails 2.2, it pulled in and initialized all of the request objects, and then it initialized and pulled in the 100,000, I think it was like 200,000 users, and initialized all of those user objects into memory, and then it iterated through them and then accepted them. The problem is that at the time, our Rails instances had like a memory, like a ceiling, so we weren't allowed to actually allocate that much memory to that particular process. So when she clicked that accept all follow requests button, what happened was we would try to load them all into memory. We would run out of memory, so there would be a timeout, and then there would be a fail whale for her. And then we would, in turn, mark that particular instance as dead. So the first time she pressed the button, she waited a couple minutes, and then somewhere on our back end, one of our front-end machines went down. But we implemented this feature using Ajax, so when she clicked the button, there was actually just like a spinner. If she looked at her logs, like I'm sure Lacey Duvall looks at her net inspector, but there would have been like, I don't know, you never know, maybe she's like a hobbyist web programmer. So if she'd looked at it, she would have seen that we were probably serving up a 400 or a 500 error, but she didn't, she just saw a spinner. And like, what do most people do when they see a spinner and nothing's happening? They press it again, right? So she pressed it again because she's like, I want all of these 100,000 people to follow me. And then she killed another server. And then we were like, at the time, like 2 servers going down isn't a complete anomaly, but she like really, really wanted this. So she kept pressing the button like over and over and over again. And before we knew it, she had like taken down a large percentage of our front-end machines. So it was like one user using a feature in a way that we'd never expected it. And it like really killed us, right? So of course, we noticed these logs where there was an extremely large amount of front-end machines suddenly dying. And we also looked at our MySQL logs and we saw a lot of queries for one user pulling in all of her or his follow requests. So I think at the time, the plan was to just limit it to 10 at a time. So that was fine. And then all the machines went back online. But it's really unfortunate because this really simple and harmless feature, as we reached like human scale, kind of got us into a lot of trouble. And people were around the world who were trying to visit Twitter, maybe to see Lacey Duvall, maybe not. We're getting fail whales because a large percentage of our machines were dead. So they saw the fail whale, but they just actually wanted to read her tweets. So we kind of screwed up there. And there was a quote from one of the engineers who said, growing and scaling a healthy application requires regular tending and pruning, just like growing a healthy garden. Assume that queries written a year ago will come back to bite you as you scale up. And this is a perfect example of when that happened. That particular code that I showed, I think in the most recent version of Rails, or actually 2.3 after that, they made it so it would do it in batches so it wouldn't pull all of those objects into memory. But at the time, that's how we implemented it. And of course, we got screwed by Lacey Duvall. Okay, so let's talk about unexpected traffic. So in that case, that was an example of one user using one button. Let's look at an example of many users using one button. So I was on the web platform team for about a year. This was last year. And I spent a good 6 to 8 months. My entire life as an engineer was this tiny little button here. So it was like 20 by 120 pixels. I was working on the tweet button and the follow button. So you may have seen this on the web. This is a little button that you can include a snippet of JavaScript on your website, and then we will render this little button. It'll tell you how many times the page you're viewing has been shared. And what we did is we worked with a lot of website owners to make it easy for them to include it on their page. So we had a lot of partners like HuffPo, Washington Post, and we asked them to include it on their site. So the idea was create a simple button. People will be able to use and access Twitter easier. And people around the web, when you're browsing the web on your desktop, will see this button, click it, and then create tweets. Seems really simple, right? So we built it. It worked. A lot of people started to use it. Then a lot of people started to use it. And sooner than later, there was about 1 million, 2 million websites that were using our little buttons. So we were hosting these buttons. But when you I mean, we already had a lot of traffic. So Twitter is one of the top 10 most visited pages in the world. But when all of the other 100, when all of the other 1,000 websites, top websites in the world, use your components, they were all referencing resources on our servers. So suddenly, a million websites adopting the tweet button meant that we were getting about 4.5 billion requests a day to this tiny little button. And this button itself, like, it's really simple JavaScript, HTML, and CSS, but 4.5 billion requests per day means that a lot of crazy shit can happen. So, specifically about size, right? The tweet button itself was about 200K, which is pretty big, so we tried to trim it down. We removed all of the libraries because we didn't really need jQuery. I know a lot of people love and tend to use jQuery, but in this case, we only needed a couple of CSS selectors, so we removed that. That got us to about 110K. We minified everything. That's like pretty common practice for front-end optimization, so that got us down to like 58K. The little bird image, we didn't necessarily need a GIF or a PNG for that, so we could use a data image. So that reduces our HTTP request by 1, and that saved us like 4K. That's kind of good, but we also, I mean, every browser will support gzip, so we also gzipped the package as it goes along. So that got us down to like 22K. So we've made a huge improvement here. But unfortunately, and this happens whenever anybody builds something at Twitter, the question is, well, how is this going to scale up? Is this going to support human scale? And in this case, a 22K file served 4.5 billion times a day means that we're serving about 100 terabytes of like CSS and HTML. And that's a lot, right? Like 100 terabytes of 20K little images of birds that people click on so that you can tweet. And we have to pay for all of this traffic and bandwidth. So we work with a lot of CDNs, and we have bills that come in every month. So when I deployed this code, I remember getting an email from finance and our CDN team being like, what the fuck happened this week? And I was like, oh, like we added a new button. They're like, no, man, like this is costing us millions of dollars. So I was like, oh, shit, okay. So we worked for a couple weeks to try to get the size down. We worked to try to figure out everything we could do. But end of the day, we really couldn't optimize the code that much more because it was still like a couple hundred lines of JavaScript and it was still a couple hundred lines of CSS and HTML. But again, they were like, at least cut this cost in half because this is costing way too much money. So what we did is we looked at the logs. So these were the request logs for the month after the deploy. And the way that the CDN bills us is they bill us as a function of the highest peak traffic of the month. So obviously there's an anomaly here in that there's this huge spike right in the middle of the graph. And I looked at it and I was trying to figure out what this was. So I spent a lot of time looking at our logs and I saw this spike and I realized that that correlated with when I did deploys. So typically, whenever I made updates to this little button, I would grab lunch and then like grab a drink and then sit at my laptop and then I'd press the deploy button. And what that did was it would rebundle my code and then ship it and then purge all the caches around the world. So at around 1 p.m. Pacific time, when I was finished my lunch, I would deploy a new version of the tweet button. But as a result, as you can see in this graph, it meant that there was this incredible spike of traffic, which meant that we were basically getting billed twice as much as we should have because as far as the CDN cared, they were like, well, I mean, that was your peak usage, so we're going to charge you and assume that that's how much traffic you used the entire month, which obviously wasn't true. So despite all of the changes that we made to optimize how big this thing was, the most intuitive thing was to do a deploy in one of those troughs. So those troughs are about 1 a.m. Pacific time, which is perfect because that's usually what time I'm like really working and like alone and no one's in the office. So it's like, all right, well, let's try an experiment where we just do a deploy at night. So the next time we did a deploy, there was basically no bump in traffic, and this is how we're doing our deploys right now, and it's saving us basically half of our CDN costs. But the only way we could have discovered this is by first getting an angry email by finance. But after that, looking at the logs and realizing that when you're dealing with incredible scale, you see these weird patterns, usage patterns. So people always say that like the internet never sleeps. But in this case, it kind of did. So I was like the only one in the office at like 1, 2, or 3 in the morning, and I'd do a deploy, and like it would just silently work, and I wouldn't see any bump in traffic. And I wouldn't see any angry emails the next morning. So this was kind of a nice little hack that we discovered. And this kind of weird usage pattern you can see elsewhere. So the first graph was usage by day. This is usage by week. And you can see these big dips are the traffic on weekends. And it's kind of a, like, you wouldn't expect that. You might expect people to use the internet more on weekends. But what we discovered is the most ideal time for us to do deploys with having the least, like, disruption is like Sunday at 1 in the morning. I didn't want to do that, so I still do them on like Tuesday night or something like that. All right, so the last example I want to go over, this isn't really about fails, but this is just about generally what it means to be deploying code to everybody in the world. So again, every person on the planet. So this is our logged out page. This is where users can come to Twitter, learn about Twitter, sign up or sign in. And this is the version of the sign-in page in English. So we're very slowly ramping up support for languages around the world, but of course, only a couple years ago we were only in English, and that is not really human scale. That is not reaching every person on the planet. So when we looked at our usage logs, this is I think a year and a half ago, 2 years ago, we noticed, we try to prioritize these things and rank them, but it's like, okay, in Russia, there was about 0.68 of our user base was using Twitter. And that's like, when you kind of look at those fractions or those numbers of how many users are using that, like 0.68 represents less than the number of people using IE6. And like a lot of people, web developers are like, oh, IE6, it's such a low amount, you don't even need to worry about it. But when you're talking about users and you're talking about like people around the world, you can't just look at this as like a relative percentage. That represented like 1.3 million people somewhere in the world. And in fact, this is 1.3 million people in Russia that were using our site, and despite the fact that the website wasn't even translated into Russian. So perhaps these were users that already knew English. Perhaps these are users that just wanted to use Twitter, so they didn't really care that they couldn't read what it said. But I mean, I'm a native English speaker, so it's hard for me to grasp what it means to see a site that I can't even read. And in fact, if I can't even read the sign up form or the sign in button, nobody's going to use or nobody's going to sign up for your service. So the obvious thing to do in this case, we translated the site into Russian. In the same day, we translated it into Turkish. And the day, I think up to the hour that we did the translations, we saw an increase of signups by 215% in Russian, or in Russia, and 121% in Turkey. And every week or every month, we're trying to roll out new languages. And every single time we do this, we're onboarding new users from different parts of the world. So again, when we looked at that original stat of like 0.6% of the world using it in Russian, it seems so insignificant, but when you actually look at the human element of it, you're talking about millions of people that you're denying service to your product. So something as simple as translating can make a humongous difference. So how did this look from an engineering perspective? We basically have an engineering team dedicated to supporting the easy translation of every string that we use in our product. We have an internationalization team. This is an example from the tweet and the follow button, where basically the string title for the title is not just a hard-coded string. It's something that runs through an internationalization preprocessor. And one of the engineers joked right after we did that deploy that amazingly, when people can read your sign-up form, they will sign up more, which seems obvious in retrospect, but again, this allowed us to get millions of more users. And one of the wins that we get from the number of people that are using Twitter is we can use the power of the crowd. So our entire service is translated by users. So we have a translation center at translate.twitter.com, which shows all of those strings. You can choose which language you like. So if you speak Russian, you can log in, and you can actually help us translate these strings. So when we launched the service in Russian, it was because of the help and effort of over 700,000 users around the world who electively signed in and helped us translate the site. We have people around the world that are really passionate about our product, so when they saw that their language wasn't supported, they were willing to help out. So, like, what do all of those examples mean? Unexpected things are going to happen when you're dealing with human scale. It's unavoidable, right? I showed you some kind of terrible things that happened. I showed you some kind of cool things that happened. But from an engineering perspective, it makes us ask a lot of questions. So when somebody asks me, Ian, you need to add a new button to the site, it seems like a really trivial task. And if I was at a really, if I was just at a startup and I was just trying to get the product out the door, I would probably just hack a button on the site and then I'd be done with it. When I joined Twitter, I chose to be in an environment where I'm going to be deploying code to millions of users. So I have to approach this with a bit more diligence because I have this responsibility that I owe to my users. So adding a simple button, people will start asking questions, and other engineers in the company will start asking questions, and I'll start asking questions to myself, and before I know it, I'll be like overwhelmed with all of these kind of potential what-ifs, right? But that's okay. So let's talk about some of the ways that at Twitter we manage these risks and we answer these questions. Because if we just sat around asking questions and worrying about shit breaking all the time, we wouldn't ship anything. So how do we actually deploy code at Twitter? So the first step is to be proactive. Everybody in this room is studying like engineering or computer science. Like we're all trained and we're all educated to think about the corner case, to think about all of the what ifs, to think about these weird cases that a lot of people in the world wouldn't really think about. So being proactive means planning for what we can predict. I'm a front-end engineer, so obviously I have to do a lot of browser testing. This was the tweet I sent out right after we deployed the tweet button, and it was a picture of like the browser testing matrix that we did for that one tiny little button. And we had 3 other people helping with this, but we basically tested this tiny little button in every browser that we supported. And that was a combination of using a ton of VMs and a ton of like just crappy laptops that we had. And this is being proactive. This is anticipating, well, what happens if a guy in IE6 loads this? Does it work? I can't just assume it will. I have to actually confirm and verify myself. And this is something that I know, because if I look at our usage logs, I know that people are using Twitter in Firefox 3 all the way up to the most recent version. So we had to test that. Same with Safari, Opera, Chrome, and all of the browsers. But that's the easy one. Unit testing, components, module testing, every use case, every single thing that can happen, we have tests around. On the left, there's a really simple spec test for, I think, tweeting. We try to enumerate every combination of scenarios that could happen, capture in a test case, and make sure that it passes. When we're talking about deploying code to hundreds of millions of users, yeah, I cannot sit beside all of these users to see if it's working, but what I can do is write unit tests that act as a proxy so that I could simulate what it would be like to be one of these hundreds of millions of users. On the right here is a unit test for how we're doing our number formatting in Japanese. Because the way that the formatting worked, and I didn't know this, I learned while I was building this product, was they don't group in groups of 3 or groups of 2. It was something different than the way that we did it in English. So I had to write unit tests to make sure that our library supported it properly. And these are all the kind of corner cases that I'm talking about. And the best way to prepare for them is to write tests around them and make sure that nothing bad happens. Lastly, we do a lot of integration testing. So we use technology like Selenium and WebDriver. So you're actually writing tests that open a browser and then simulate functionality and features. So on the left, we have the integration test for our sign-up page. Of course, we always want to make sure people could sign up. And once this test is written, it verifies that on twitter.com, user will always be able to sign in and create a new account. If that ever broke, this test would fail and we'd know that something's wrong. On the right, we have another unit test for tweeting. Of course, if we let people sign up but they can't tweet, that's also something that would really suck. So we have a unit test, or an integration test rather, that verifies that we can test that particular feature. And because these are all tests that are written in code, it was a combination of JavaScript, Ruby, and I'm talking specifically for the front end, so this is for twitter.com. Over the years, we've collected a total of around 20,000 tests. So when I write a single line of code right now for Twitter, I have to verify that all of these tests pass, and I should also be adding new tests. We have 45 dedicated servers to running these tests, basically 24 hours a day. So if a new engineer comes in and breaks functionality, a test that may have been written maybe 3 or 4 years ago might now fail, and the engineer should go see what happened, and then they can make corrections to their code or corrections to the test. But basically, in order for an engineer to ship code at Twitter, they need to write tests and they need to verify that they didn't break anything else. And a general rule of thumb that I've always used as an engineer is if you can't test it, then you're probably doing it wrong. A lot of people always say, oh, the system I'm building is way too complicated to test, or the way that I'm building it makes it really difficult to test, or almost impossible to test, which is usually kind of bullshit. It just means that they don't want to do it, or they're too lazy to do it. Testing is so critical for us because, again, there's no other way that we can capture all of these use cases and scenarios. So if you're building a piece of software that you can't test in some way, then you need to rethink how you build it so that you can test it and verify it programmatically. And the last thing that we do from a proactive perspective, and this is kind of the last line of defense, is code reviews. So every single line of code that gets shipped at Twitter has to be peer reviewed by at least one other engineer. This is for a lot of you that are going to be joining companies soon or interning at companies. This is an incredible way to learn and grow your skills as an engineer. Reading other people's code reviews, getting code reviews from other senior engineers. They will give you feedback on your code. They'll tell you style mistakes, and they might catch little small errors that you didn't expect. So this is a famous code review that was popular on Hacker News about a year ago. So this was for Project Bumblebee. This was like the diff for the install script. This wasn't at Twitter, but In this example, it was like a really simple, harmless install script, and the author made a little typo there in the corner. I'll zoom in on it. But basically, he added a space in by accident, so when you ran the script, it basically deleted your /USR directory, which really sucked, and it was patched really quickly, but these are kind of things that you want to be able to catch in a code review. Yeah, that really sucked, and it was brutal because you can find it if you Google around for it, but it was called the most epic commit of all time, and there was hundreds of animated GIFs posted after this with all sorts of different things on it. But avoid doing this because this is a simple human error. Obviously, he didn't mean to do this, but they caught it and then they fixed it. I would have been really pissed if that happened. So that's a bit about being proactive. We can also be reactive because we can't predict every single thing that's going to happen or everything that's going to break. So being reactive means doing a lot of monitoring. Every single system that we build at Twitter has monitoring. This is a dashboard of one of the services that we have. Basically, if you're building a new system, back end or front end, there should be measurable kind of things that we can use as health checks to make sure that our system's working properly. If we just deploy code and assume that it's working, we wouldn't have caught those errors that came up during that Lacey Duval follow all button. We wouldn't have caught what was going on during the Super Bowl. Yeah, well, during the Super Bowl, we knew that we were falling over. We knew exactly what was going on. We knew exactly what was failing, so we knew where to fix and improve our site. We have an entire team dedicated to doing visibility and observability, which means they build dashboards, they build tools for us. So if I build something as simple as a follow button service or a tweet button service, I can build these metrics and dashboards to see every little bit of statistics that I want. And as an engineer, this is so critical because these are the life signs on how your code's actually doing in production. So this is a dashboard of all the HTTP errors, all of the latency, all of the response times, all of the things that you might need to verify if somebody asks, how's your service doing? You need to be able to point to graphs like this and say, yeah, it's doing fine. Or, no, something horrible is going on. I'm gonna go into the office. And, all of the graphs. So this is the dashboard that I use to monitor the follow button, I think. And it's a lot of crazy stuff. I have a much bigger monitor than this, so the font's not so squished. And of course, we also monitor behavior. I showed you the graphs for our signups after we translated the site to Russian. We have a framework that is in place for all of our products to use, so we can log every single button click, every single page impression, how people are using our features. So the previous kind of example was about how we make sure that our systems are healthy and are running. This is verifying that our products are running healthy, that our features that we're creating are healthy. Perhaps there was a JavaScript error and the sign up button didn't work. Suddenly we would see signups drop and we would know exactly what happened because we'd see that the clicks on that button have gone down, so something's going wrong. Monitoring behavior of your features and your functionality is the only way to verify that you've made an improvement to the site or the feature's doing what you actually expect it to do. And just like testing, if you say that you can't monitor it, then you're probably doing something wrong. As you guys join companies or start your own companies, you'll learn to develop and build systems that are very easy to monitor. You'll get a good grasp of which metrics are actually important. You can't monitor every single thing, or you could, but maybe not all of those metrics are important to you. Just through experience, you'll eventually find what's important, what's not important. Building and shipping a system without having any monitorable metrics is just completely crazy. It's like flying an airplane with the windshields down. You have no idea where you're going. You have no idea where you've been. So monitoring is so critical. And the last little trick that we use at Twitter that I'd want to talk about is controlled feature releases. So this is a feature that I worked on and launched a couple months ago, and it was the ability to, when the user shares a URL, instead of just showing the tweet with the URL, we'd show a preview of the content. So in this case, it was a link to a Kickstarter project. So we worked on this project for several months, and when we were ready to deploy it, we shipped it into production, but we shipped it with the feature turned off because we had no idea how the feature might behave in production. We had our guesses, we had all of our monitoring set up, we had tests set up, but again, all of our caches were cold, the feature had never been on in production. So we did a controlled feature release, which means over a week we slowly started to turn the feature on. So first 1% of our users could use it, then 10%, and as this was getting dialed up, we would actually see and view in our metrics that the feature was behaving properly and all of our services were healthy. We went up to 50%, 80%, 90%, and eventually 100%, and we were safe to say that this feature was good to use. The other thing that we can do with this kind of control is if this feature or one of the services is misbehaving, we can easily turn it off without doing a deploy. And from the code perspective, it's literally like wrapping large blocks of code around an if statement. This is the code used to determine whether we were going to display something inside of a tweet. And you can see that that whole thing is wrapped in what's called a decider block. That's the name of the technology that we use. And it basically says if that number is 0, don't show it, otherwise show it. So all of these things that I mentioned and all the proactive and reactive ways that we can be better engineers are important because in a typical software development flow, you're working with a product manager and an engineer. The product manager might ask you to implement a feature like, could you add a button that makes it so we accept all follow requests for a protected account? And you're going to say, sure. The PM is not necessarily going to ask you, can you make sure it doesn't take down our website when a porn star presses it 50 times? That's not going to be a question that you're going to get. These are the kind of things that it's your job to anticipate. Because again, that's not necessarily in the product requirement. The feature to work and not take down the website is kind of an implied feature requirement. So as an engineer, it's your job and your responsibility to take care of all of those other things. So kind of like summing this all up, when you're deploying code and when you're shipping code that a lot of people are going to use, things are going to go wrong and shit's going to break, and that's okay. But if we prepare for it, if we do the proper steps, if we apply, the proper engineering diligence, we'll be able to anticipate this and react to this as it happens. So at Twitter, we've come a long way, and we've kind of applied this methodology. Twitter started as a piece of software developed for one person. So this is the first tweet that was ever sent by Jack back in 2006. And it was, just setting up my Twitter, and he was the only user. I think he sent it, and obviously nobody saw it because he was the only one on. So this is software for one person. But of course, as I mentioned, we want to reach every person on the planet, and we've started to scale this out. And this is a tweet that was sent not too long ago from an astronaut in space, and it was a photograph of the world. And this is where we want to go. We want to reach every person in the world, and we want to build things the right way so that our users can enjoy the software without seeing any errors. I thought this was a kind of a cool tweet. I have no idea how he sent a tweet from space. And I'd be really curious to see what the geo would say, like sent from orbit. I don't know. But again, a lot of things can break. There's a lot of questions that you need to constantly ask yourself about what could go wrong. There's this responsibility that we all have as engineers. Like we've chosen, or many of you will choose a career in software engineering, so we have to take our practice and our discipline quite seriously, and we have to apply these kind of concepts and practices. There. Thanks. Yeah, that's everything. So I think we have like 15 minutes for questions. Is that right? Awesome. So was there any questions that anybody had? Yeah, right here.
So you said that you do a lot of code reviews at Twitter.
Yeah, so we do code reviews for everything that gets shipped. A lot of different, it depends on the team. I try to do as much pair programming as I can. I did that when I was learning, when I joined the company, and now that new engineers are joining, we'll code together. Maybe if it's just getting the feature started, or maybe if it's finishing off a feature, but we do kind of like that extreme programming style where one person will be on the keyboard and one person will be kind of talking about it. Maybe not as much anymore because the company's grown out, but definitely some teams still do that kind of practice. Yeah.
So that stats thing you did, is that something you...
Yeah, so there was two kind of dashboards that I showed. One of them was for internal metrics. Actually, both of the systems were built for internal use only. For specifically about monitoring your processes and monitoring your services, we open source part of the component. It's a project called Zipkin. If you go to GitHub on our Twitter open source page, you'll see a project that was released by our team, and it's specifically about doing profiling of backend systems. But you're right, a lot of teams, a lot of companies, no matter where you go, have built out services like this, specifically about monitoring either features or your systems. Yep.
You mentioned some of the cache.
Like specifically like how APIs have affected us.
Yeah, have like any almost catastrophes.
I think like one of the most common themes that we've had is that like whenever world events happen, it directly correlates with the health of our service. So whenever like I think New Year's Eve happens, our service kind of gets pushed to the limits, and that's a combination of our APIs being used by our third-party apps and also on Twitter.com. In terms of catastrophes, nothing specific that comes to my mind, but again, like whenever big things happen in the world, it really pushes our entire system to its limits. It's kind of like bittersweet because it means people are using Twitter, but at the same time, like our servers are going like bonkers. Yeah.
So when you had that Super Bowl problem, did you guys just pretty much...
Yeah, okay, so I didn't mention a couple things, but like we were watching the Super Bowl in the office, and it was like really brutal because we basically wanted it to be the most boring game ever because every time something eventful happened, the site would go down. So throughout the entire game, whenever somebody scored, we were all like, oh, fuck, like something bad's going to happen. And it did. But what we did, like we knew that we were going to have to kind of double down on our infrastructure. But at the time, what we did was we disabled some features that we knew were high load but low visibility. So I think at the time we disabled follower count temporarily for that 3-hour period, and that bought us a lot of time and it bought us a lot of load, and we turned that back up. But you're right, basically when the game ended, everything kind of went back to normal, and then we had to come up with a plan. But yeah, I showed you how we can control features. We turned off a bunch of features. The two core features that we can never turn off is signups and tweets, because that's like the core service. But there's other things that we were able to kind of dial down a little bit so that we got enough headroom to kind of get us to the end of the game.
And do you guys also try to predict things?
Yeah, definitely. So right after the Super Bowl, shortly after, right after the game, we were like, okay, we need to fix this. This can't happen again. And we looked, because we learned that sports was one of the most heavily used kind of events for Twitter. We looked forward, we're like, is there any other major sports kind of thing happening soon? And we looked in the summer, and it was like the World Cup was coming up in a couple months. So that was like the timing that we had to anticipate for. So a lot of infrastructure work was done. And when the World Cup happened, like it was intense, but like we kind of made it through. And just I showed the graph for the 2012 Super Bowl. We're always anticipating events like this. People are always aware that this is when the service is going to get a lot of traffic. So we're kind of alert and preparing as much as we can. Yep.
Okay, so you mentioned a few types of tests. How do you handle performance when it's so critical?
So the tests that I showed were mainly for like the front end and like the web stuff, because I'm a web and front end engineer. I've done a lot of load testing before. I've just used like Apache Batch and stuff like that, but I know some of the back end infrastructure guys have other tools that they use for performance testing. A lot of those are just to kind of get predictions or estimations of how it's going to handle the load, but even when we do those tests, sometimes we get unexpected usage. I wouldn't be able to say too much about kind of the back-end like stress tests that they use, but I know that we do that kind of stuff. I just didn't, I don't have that much experience with that. Yeah.
So earlier you showed you had the 8 a.m. in the morning.
Yeah.
So what happens in like the,
So in that particular case, we did have global adoption, but it seemed that it was like very heavily skewed to like North America. We're obviously trying to grow out like globally, internationally, and at the same time we're doing co-location and CDNs, so you have like specific zones where you're serving it. And when this becomes more like of a flat graph or maybe spikes on the other end, we can adjust our deploy strategy, or we could do time deploys depending on which region we're talking about. So deploy it to region 1 first and then region 2 later. But again, this is just stuff that we're going to have to learn as we monitor and as the service grows out. Cool. No more questions? All right. Thank you very much.